Same day as 10.4. I thought that one went by the time I did take number 3, so I thought I would try to do 2 in one day. So yes, I am in the same clothes. Today next we're gonna do 10.5, add and subtract, and then there's also a tie-in with the last piece that we learned yesterday, rationalizing the denominator. So if you have not practiced that skill and haven't done your homework for that, I would suggest you go back and kind of revisit that, make sure you're confident, because this builds on that. It is not a separate concept today. All right, so more operations. I'm not going to write the title. You have my handwritten notes for 10.5. So our first example looks like this. All right, so here's the deal. As long as I'm stepping on chalk, as long as the radical is the same underneath the radicand, and as long as the root is the same or the index, then you can add and subtract the numbers in the front. So it's just like adding and subtracting with variables. So 8 radical 3, take away 2 radical 3 is 6 radical 3. Done. However, if you have something like this, 5 radical 7 plus 2 radical 6, you can't do anything because it's like adding 5x plus 2y. Since the radicals are different, you keep the terms separate, and that is your final answer. Same holds true for the index. If you have something, say, the cube root of 2 minus 5, the 4th root of 2, and if there's no number right there when you're doing your homework, you can go ahead and add a 1, just like we do when we have an x or a y, if that helps you. And so you look at the radical, you might think, gosh, those are both 2, but because the root or the index is different, this is just done. That's your final answer. Just rewrite it. If that comes up on the homework and you don't know what to write as your answer, just like this would be your final answer, this would be your final answer. All right, sometimes you don't know if you can gather like radicals or not, because they're going to come to you not simplified. So 5 radical 12 plus 16 radical 27. All right, so my suggestion for this problem is we're going to kind of revisit again that 10.3. That skill is going to come up over and over again. We're going to simplify this, we're going to simplify that, and we can then add those terms together if the radicals match. Everything is square roots, so as long as the number underneath the radical is the same, we're good. All right, 12 breaks down to 3 and 4, 4 breaks down to 2 and 2, a pair of 2s, one guy cancels, anything that's circled comes out, anything that's not circled stays underneath. When this 2 comes out of that radical, there's a 5 right there, so just a reminder that it's multiply, it's going to be 10, not 7. So this is going to be 10 radical 3. Let's break down that 27, 9 and 3, break down the 9, circle your pairs, a 3 comes out, a 3 stays under. That 3 that comes out has to be multiplied by that 16. 3 times 16 is 48. 10 radical 3 plus 48 radical 3 is 58 radical 3. So if it matches, put them together. If it doesn't, keep them separate. All right. So you would think that would be it. We've multiplied, we've divided, we've added, we've subtracted, but now we're kind of going to put some of those skills together. We're going to look at more than one term, distributing, FOILing with radicals, things like that. So what happens if you have a radical in front of a binomial? Well, you're just going to distribute the way you always have. So multiply here, multiply there. So there is no radical here, so we're just multiplying that number there in front of the radical. 2 times 6 is 12. So this is 12 radical 3. When we multiply here and here, remember it's going to be the outside numbers multiplied by the inside numbers. So 2 times 3 is 6. 3 times 3 is the square root of 9. But the square root of 9 is 3. And so this becomes 6 times 3, which is 18. If you notice your book writing this backwards, when we get to 10.8, there is a very specific way you need to write the answer. And I'm not going to be as flexible just so that you have good habits. I am not going to care how you write these answers here. I'm sure if you analyze the book, sometimes the radical would be in the front, other times the radical would be in the back, depending on what section you were looking at. So, all right, let's do it again. 4 radical 2 times the square root of 3 plus the square root of 5. I don't really know why I wrote down 2 examples. It seems like this is just the same as the last one. So I'm sure you guys are going to be okay. 4, there's a 1 right there, so 4 times 1 is 4. 2 times 3 is 6. Plus, there's a 1 right here. 4 radical 5. No, excuse me, radical 10. 2 times 5 is 10. You cannot put those together. The fact that the 4's match don't mean anything. The radicals don't match, so you can't put those together. All right, let's start to FOIL. So now we're going to have a binomial with radicals times another binomial with radicals. For instance, the square root of 7 minus the square root of 2 times the square root of 5 plus the square root of 2. All right, so first term times first term, there's the f. 7 times 5 is the square root of 35. 7 times radical 2, there's the o, is a positive square root of 14. The I is the 2 inner ones. Negative radical 2 times radical 5 minus radical 10. And then the very last ones right there, there's the L. So a negative times a positive is a negative. 2 times 2 is the square root of 4. Sometimes you're able to add some of these radicals together, sometimes you're able to simplify, and sometimes your answer is just done. So kind of take a glance at your answers, see what you can do. The only thing you can really do right here is simplify there. The square root of 4 is 2. You can rewrite the whole, I'm going to rewrite the whole answer. If you chose not to on homework, that would be fine. And that's the final answer. There's nothing you can do. Let's do it again. We're going to start off with one that looks just a little bit different, but we're going to FOIL it nonetheless. Let's say you have 3 plus 2 radical, I chose 10. Seems kind of large. Usually I try to keep my numbers here between 1 and 9. All right, so when we square this binomial, it's not just the first guy and the last guy. You need to rewrite it so you don't forget anything. And now you FOIL. And in this example, we are going to end up with some things that can add together. So 3 times 3 is 9. The outside piece is going to be plus 6 radical 10. The inside piece is going to be another 6 radical 10. The last piece right here, out times out, so 2 times 2 is 4. 10 times 10 is the square root of 100. The square root of 100, 100 is a perfect square. This radical 100 is 10. So when I rewrite this, 4 multiplied by 10 is going to be 40. So you can rewrite everything, or you can just kind of mess with that one until you find out what number it actually is. You know I'm pretty flexible on that. 9 plus 40 is 49, because now those are like terms. These two guys both have radical 10. So plus 12 radical 10. Final answer. 10 can't be broken down in any way, so we're done. One last one. It's one of those aha moments, and it's going to lead us into our last few examples of the day. This one does have a special word. It's called a conjugate. And you'll see why it has a special word in just a second. So we're going to go 5 plus radical 3 and 5 minus radical 3. And so 5 times 5 is 25 minus 5 radical 3 plus 5 radical 3 minus the square root of 9. So that's after our first step of foiling. I just kind of went for it there. Notice right here, these guys are opposite, so they are going to cancel. Radical 9 is 3, so this whole thing simplifies to 25 minus 3, or 22. And so your book would call this an aha moment, because we started off with binomials that had radicals, and we ended up with a number that didn't. And here's why that's important. Just like we did in the last section where we rationalized the denominator, the rule says that you cannot have a radical in the bottom of a fraction. So what do we do if we have something that looks like this? Well, let's do it the wrong way so you see why this doesn't work. If we just apply exactly what we did yesterday, and you just saw that radical and you said, okay, let's multiply top and bottom by the square root of 3. Earlier I was stepping on my pink piece of chalk. There it is. So radical 3 over radical 3. Maybe you can see where this is headed. So if I distribute here, this would be 5 radical 3 over, multiply there, 4 radical 3 minus the square root of 9, and of course that simplifies, but we still have a radical in the bottom. So that method won't work. What we need to do is we're going to multiply both the numerator and the denominator by that conjugate that I just had up on the board. All right, so I put parentheses around that. Excuse me, if you look at my notes, I think it's the chalk dust getting to me. If you look at my notes, they always come in parentheses, but I added them. The problem doesn't start like that, so you're going to want to add in your own parenthesis. Okay, here's the important part. This stays the same, that stays the same. This is the only thing that changes, so we're going to change it to a plus. If it starts out a positive, we're going to change it to a negative. So we are going to multiply top and bottom by the conjugate. And so now in the numerator, you just multiply it through. If you end up with radicals, it's not a big deal. So we need to distribute. We end up with 20 plus 5 radical 3. You hear my dog in the background trying to escape. Maybe she doesn't like math, I don't really know. All right, and then on the bottom here, you're gonna FOIL. So 4 times 4 is 16. You have positive 4 radical 3. You have minus 4 radical 3, and you have negative square root of 9. Do you need to keep writing that if you know it's going to drop out anyways? Once you get used to that pattern, I would suggest just doing first and last, because you know those are going to cancel. The square root of 9 is 3, so 16 take away 3 is 13. And you're done. And notice that the radical has moved up to the numerator. There is no radical in the bottom. All right, our last problem. Nope, I have 2 more for us. Lucky you. I have 2 more, just so that you can watch a few more of those. This next one, I just made the numerator 1 so as not to complicate things. And then I picked radical 3 plus the square root of 2. you can make sure that, even though there's 2 radicals in the denominator, you'll kind of convince yourself here that that radical does indeed go away. This is the guy that changes. Nothing else changes. So square root of 3 minus the square root of 2. Square root of 3 minus the square root of 2. I would put parentheses around everything. All right, so since the numerator is just a 1, you know that's the final answer, the numerator. So we'll write that in a second. Okay, multiply here, the square root of 9 minus the square root of 6 plus the square root of 6 minus the square root of 4. These guys drop out. The square root of 9 is 3. The square root of 4 is 2. 3 take away 2 is 1. And so there isn't even going to be a fraction for this one. If I multiply this through, this is the numerator. That ends up being the final answer because the bottom's just a 1. All right, last problem for 10.5. I did make it a little bit more complicated, so bear with me as I kind of find different spots to probably show my work. All right. So, we don't care that there's a radical in the top. Ignore it completely. You want to switch that guy right there to a plus. That's all you're looking at. Ignore that completely. So multiply 3 plus radical 3 over 3 plus radical 3. Do our parentheses. And then you're going to kind of maybe split your work a little bit. So I'm going to do this numerator part first. So 7 times 3 is 21, plus 7 radical 3, plus 3 radical 2, plus radical 6. There are no common radicals there at all. So that is the entire numerator. For the denominator, bear with me as I kind of do it down here. 3 times 3 is 9, plus 3 radical 3, minus 3 radical 3, minus the square root of 9. These cancel. This can be reduced to a negative 3 because the square root of 9 is 3. 9 take away 3 is 6. And I would leave your answer like that. If your book for some reason splits this up as multiple different fractions, I don't really think that comes up until 10.8, but I suppose it's possible that it would be 4 different fractions. This one can be reduced and you would be able to take a 3 out of the top and the bottom. So just make sure you would reduce, but there's no reason to do that for my sake. All right, just one big fraction is fine because again, we're kind of just hitting those highlights all the way through to chapter 12.1. We're gonna do just a little bit of that. Stay safe. I hope you all are doing well. I did 2 videos in a day, so I probably won't make the next one until tomorrow, so you'll see different clothes. All right, happy Friday, everybody. Bye-bye.